Are long, it's not my fault, it's your guys' fault.
I want it to be super pertinent.
Trying to figure out what's going on. That's not good.
Like, it's different. Someone could just go get like a bachelor's in philosophy, but still go like get a sales job and make 120K a year selling appliances. Like,
yeah, we really want to.
But with programming, like our majors, you have to be there and learn it and pay attention because that's actually what you'll do. You're not going to just go sell hospital equipment after you learned coding.
You're actually going to do the thing that you're actually trying to
Exactly, yeah.
It's kind of weird, right?
It's rare, which is weird that it's rare that that's how that's working.
Yeah, like those people who get a bachelor's in political science.
You know what else is really cool, though, is the minor in business first doesn't require Econ 2, which is amazing because Econ 4 is literally awful right now. I'm not looking forward to accounting though.
What are you going to play on those, fun calculators?
Working on his office number?
He did.
Okay.
It's weird that that's called Business 18.
They're not really an hour and a half lectures, but I would start. So really, a little bit. Here's your riddle for today. Right? You're at a family reunion. There was one grandfather, one grandmother, two fathers, two mothers, 4 children, 3 grandchildren, 1 brother, 2 sisters, 2 sons, 2 daughters, father-in-law, mother-in-law, and 1 daughter-in-law.
Too much information.
You got to figure out how many people were there. More than 1, less than 100. Those are your parameters.
It's one of each, right? 1, 2.
Yeah, grandfather is a father, right? So you got your double dipping there. Anyone want to throw out a random number?
27.
2. It's more than 2. It's less than 27.
Oh.
More than 5.
11.
Less than 11.
It's 7.
It's 7.
Yes! Suck it.
What?
You get
Because some of them count for multiple.
you get boy, girl, and girl. Right? They're like the bottom of the family tree. Right? And so then they have a mother and a father. Right? And this father has a mother and a father as well. That's 7, right? So if you look at it, 1 grandfather, right? Everyone good? Here's a grandfather. 1 grandmother. 2 fathers. 2 mothers. 1 child, 2, 3, 4 children. Right? Apparently she's not a child of anybody. Right? 3 grandchildren. A brother. 2 sisters. 2 sons. 2 daughters. Right? A father-in-law, a mother-in-law, and she's a daughter-in-law.
I don't think it works. No, you can't count her because it's not that her family.
Yeah, exactly, right? That's the other thing.
Yeah, didn't you know that already?
Assumption too, we don't know.
She's not a daughter of this family, she's a daughter-in-law.
Yeah, right? So there you go.
I am
She's still a
confused.
daughter. We think.
It's a small family reunion.
What?
Yeah, small family. I don't know where the mother came
Mother's
from.
family doesn't like the father's family.
What is
Are you guys so
Computer
excited to
Computer
not
science?
do classes today?
Wait, what?
We're having class, but we're not doing classes.
Oh.
Oh, man.
So we're going to move to a new topic. That being said, code assignment 3B is class oriented, right?
So we should know everything.
You should know it, right? I've given you everything that you need about classes for the rest of the semester.
Lol.
Okay.
That's where I lol.
There is, but we have as much as we need.
But what about
Okay.
database
We'll fill in
structure?
stuff that will help with classes, but as far as syntactically, we can't have everything. This is kind of cool and kind of scary all at the same time.
You have the
Right.
knowledge.
That being said, right, 3B is a great place for you to continue practicing that, right? Assignment 4 will be the combination of what we're going to learn today, arrays and classes. So that'll be fun when we get there. But arrays overall conceptually aren't terribly hard to understand, so hopefully today will kind of be a breath of fresh air after kind of doing classes and figuring out right where we're going.
Don't
what
arrays
calls
store
what,
multiple
that calls
values?
what, that calls what.
Is that something?
Sound good? You
Right.
handle that?
And usually they
All right.
start at like 0.
So we're going to talk about arrays.
Yeah.
We'll get into the syntax for those
Some
arrays.
JavaScript.
And then we'll look at how arrays exist in memory and why that can be a good thing and why that can be a bad thing. Everything exists in memory.
True.
Right? So arrays are a way for us to store a lot of data, a lot of information of the same type.
Nice.
Right? When I say type, I mean what?
Integer.
Int, double, char,
Full,
string,
float,
bool.
void.
And now any classes,
Wait,
right?
no.
Could be burger. Right? What else do we make in this class? I don't know.
Pi.
Pie, right? Could be burgers, could be pie. Right?
Cars,
Could be dragon.
calendar.
Could be a dragon, a calendar, a day of the year. Right? Could be all those, right? So any of those, right? So an array is to store a bunch of data, all of the same type. And there must be hopefully a reason why we're storing a bunch of data.
And you'll learn that in Business 18.
Yeah. Right, come back next week. Find out more.
In 2 years, when I decide to teach it again.
So why might we use arrays, right? Think of a program that's going to read in 5 test scores and then perform some manipulation on those test scores, right? You want to find the highest test score. You want to find the lowest test score. Hopefully it's not yours, right? You want to find the average test score. Does that make sense? Right now, right, how would I do that? I want to get 5 test scores. What am I going to need?
5 things.
5 things, right? 5 variables to hold that data. Right? I want to agree that they're all the same types though, because all test scores are the same.
Yeah.
So I need to store 5 things of the same type.
Doubles.
And then somehow I have to go through all of those variables, right? And like add them together and divide them by 5 to get the average.
That's awesome.
Or somehow go through each of them and say, yeah, you're bigger than that one, and nope, you're not bigger than that one, and, right?
So you need a function for each to do the operation.
A function would make it easier, right? But overall, right, not really easy to do with, right, variables. It also doesn't scale, right? What if I, instead of 5 test scores, it was 10 test scores? Right? Then instead of creating 5 variables, how many variables do I have to create?
10.
10. If it was 100 test scores, I have to create how many variables? 100. That means what? Like test underscore score underscore 1. Test score 2. Test score 3.
Is that where you would like push it?
Terrible, right? Huh?
Is that where you would like push the array?
Start with 0. We always start
Pop
with
it.
0. Test score 0. Test score 1. We're going to start kind of at 0 today, right? So there's our test scores, right? And what arrays allow us to do is to group all of these together in one variable. Right? That variable has a bunch of spots to store these things. Right? So that's how we would have to do it from what we know so far. But today, what we'll do is we'll put them all together and just create one variable called test scores. And test scores you see can actually hold all 5 test scores.
Will we be able to receive those if if the program doesn't already know the values?
Yeah, like with CN. Yeah, you're gonna write a program to do that thing. Sick. Be pretty cool. So this is my array, right? Basically a variable, same name, that stores a bunch of values of the same type. So let's look at algorithmically how we would try to figure out what the highest test score is. Right, with 5 test scores, visually it's really easy, right? What's the largest test score?
90.
90, right? But a computer can't just visually look at something and say, oh yeah, that's the highest score, right? So anyone have an idea of algorithmically how we would figure that out?
Add them all together and divide by the amount you added.
That would be an
Probably the average, right? I want to get the highest.
Oh, the highest?
Yeah.
Didn't you just compare the different test scores to each other?
So compared to each other, like compare 75 what to all of them and then 90
Yeah.
to all of them?
Yes.
Or 30 to all of them, would that work?
Yeah.
Yeah, that seems like a lot of work for that, right?
Okay, what's listed on array equal to 100?
You hear that? Take the first score, compare it to the next one, take the highest of those two and compare them to what? The next one, highest of that one, and the next one, right? And that's the easiest way algorithmically it is. Because to find the highest test score, do you have to look at all the scores? Yes, you have to, right? Because it could be that the one score you didn't look at is the highest score. Does that make sense? So you have to look at all 5 scores, and so somehow you have to start the first one and kind of look at each one individually. And so what we can do is basically we can just say that 75 is the highest test score, right? The caveat being it's the highest test score that we've what? Seen, right? That we've looked at. Perfect. Right, so 75 is the highest test score. Then I move on to the next test score, 90. Is that score bigger than 75?
Yeah.
Yes.
So which is the highest test score now?
90.
90. I move on to the next one. I compare 30 to 90 because that was the highest test score. Is it bigger?
No.
No. So then I move on to the next one. 85. Is it bigger?
No.
No. So then I move on to the next one. Is it bigger? No. So the highest test score is what?
90.
90. All right. We're going to learn today how we move from one to the next to the next. Programmatically, it's actually pretty easy. It'd be nice. Right? Lowest test score, same concept, right? But now instead of 75 being the highest value, it's what?
Lowest.
Lowest. Is 90 smaller?
No.
No. Is 30 smaller?
Yep.
Yeah, so it's now the lowest. And then is 85 smaller than that? No. And is 70 lower than that? No. So the lowest test score is what? 30. Okay. This kind of algorithm is called a greedy algorithm because it just takes the first value that it says and it says, yes, this is the value that I want it to be. And then it starts comparing it with others. That won't be on a test anywhere. It's good to know what type of algorithm. And we're kind of good with what arrays are, without knowing the syntax of how to do it, right? Group a bunch of values together of the same what? Type. Right? You want to group a bunch of values of different types, what should you use? Yeah, right? A class or a structure.
That was a guess.
If it's just data, I'd use a structure. If it was data plus behaviors, then I'd use a class. Not in this class, right? So do that in discrete. And if you take business 18.
Which isn't even offered for like 2 years.
The teacher's got to get his act together.
Which class is business 18?
It's like fucking survey count data shit.
Why would you need that?
Right?
It's
Because
like the
we're going to
database
store that
structure
value
stuff.
somewhere
Oh, yeah,
else,
yeah.
And we'll be comparing it back.
You have to take that class to take the database one?
You'll see programmatically.
Well, since I'm going
All right, look at the syntax. It's super complicated, okay? You guys ready? It's the type, it's the identifier, it's square brackets, and then it's how many values you want to store, or basically you think of it as how many variables that you want to have. Right? That's a lot, right? So we're taking the declaration for a variable, and what are we adding? Square brackets and a number. Can we handle that? I know we just got back to break, but I think that we can handle it. Right? So you can say int score bracket 5, which creates me an array called score that holds what?
5.
5 what?
Value.
What kind of variables?
Int.
5 integer variables, right? So
that's
the
the
store
amount.
array can store 5 values, and all 5 values have to be integers.
Wouldn't it start at 0 though? Wouldn't it be 6?
No. So
So would that be 0,
just
1,
like
2,
you
3,
can't have
4?
2 variables of the same name, you can't have 2 arrays. It's really just a variable. It just holds more stuff. We'll learn multi-dimensional arrays eventually, where you can get crazy. Yeah, I think that's what you're doing now. We have rows and columns. We'll get it. Not today, though. That's my favorite thing to say in this class. You guys are just so forward thinking. My other classes, we don't talk about this.
He's gonna talk about data so much, he won't even offer the data class.
It's like declaring these 5 variables. Okay, when I say int score bracket 5, it's like saying I have a variable called score bracket 0, one called score bracket 1, score bracket 2, score bracket 3, and score bracket 4.
Oh,
Basically,
yeah,
I
yeah.
get 5 distinct variables, but you notice that the variables start at what location?
0.
Because computers like to count at
0.
0. Right? And so that's why they started. So throw 1 out the window.
Previously, we've used the operation +1 to shift that. Can we do that here?
We can do plus plus to move the numbers, right? That's how we're going to get from the first spot to the second spot. And we will see that today. Very soon.
No way.
I like to say things.
I don't believe it.
Right? Each of these things, they're not technically variables, right? Because I have one variable, right? The array. So we call these elements of the array. So the name of the array, square brackets, and a number, right? Saying a location of where in the array you're working with, right? That's called an element of the array. So you might hear me say that.
So if you're calling score bracket 1,
Yeah.
is it int score or you just can call score?
Just score bracket 1. It is the second element of the array.
Okay.
Score bracket 1 is the second element.
The way the scores are implemented.
We're gonna get there. I have a whole part of the lecture is all about how it's stored in memory. So let's not worry about that yet. All right, the thing in the square brackets is called the index, right? So 0 is an index, 1 is an index, 2 is an index. Those are indices, right? So an element is variable plus index, right? And so that's the number in the brackets. Notice all indices start at what?
0.
0, right? Which means the last index of any array is located where?
The end.
Okay,
One.
more specific.
1 less than the value in your.
One less, right? So that would be 1 less than size, right? So the last element is always size minus 1. And the last element is always size minus 1, right?
Which is
5 elements, right? First element 0, last element 4, right? 100 elements. First element 0, last element
99.
99, right? We're going to talk today about what happens when you hit element 100, right? It's like you fall off a cliff. We don't want to fall off a cliff.
Can you add more to that though? Will you
No.
show us how to push or?
You can't make more.
Okay.
And there's a reason why, and we'll get to that. Maybe.
Damn it.
No, that's not the
Playing.
limit. You can make an array size 1,000. And then you have 0 through 999. The limit is how much memory your computer has.
Oh,
On these ones, nothing.
it's 2 gigabytes of RAM. That's nothing.
Because if you only have indices 0 through 99, well, if you go to 100, that's not part of your array, so you're somewhere else. And that somewhere else, we're going to call it falling off the cliff and do this. We don't want to do it. But we will talk about what the abyss is. Declared size is just, right, how many elements are in the array, right? That's the thing in the square brackets on declaration. Right? If we use the square brackets twice on declaration to create the array, that's the size. And then afterwards, on accessing, right, that's the index in the square bracket. Right? So we use the square brackets for 2 things. So it should make sense. If score 7 is the last element, then the size of the array is 8, right? Because if the last element is 7, and the last element is always located at size minus 1, and we add 1 to 7, we get 8. Right? Exactly. The last element was score bracket 5, then the size of the array would be 7. Base type is just the type that's shared by everything, right? So the base type could be int, or string, or double, or burgers. Right? Could be any of this.
Or burger.
Could be burgers, right?
Class.
Now we can make a bunch of burgers, right? We don't have to just make one burger or a fancy burger, right? We make a whole array of fancy burgers. Right? Yeah, array of objects. An array of objects. Right? And so this just shows you, right? For whatever reason, all my examples always use ints, but there are other types. Right?
No.
I just get a bad rap because I always use ints. Right? 1, because it's 3 letters, and 2, because it's just whole numbers, but both of those are easy to deal with, right? But you could create a double score 5, or a char score 5, or a string score 5. Could you create all 3 of those at the same time? No.
Score.
Why not?
Score.
Same name, right? They're all named score, right? So they'd have to be named different. But you can create an array with any base type, and all elements of that array share that type. So they're all doubles, they're all characters, they're all strings.
Nice. 27 page
Capital S
lecture.
score, lowercase, right? Yeah, then you could do that. Then it would work. Maybe I need to update my slides so that way officially it works. Might seem weird, but you can declare arrays in line with other variables. So I can say int next, comma, score 5, comma, max. How many variables did I create?
3.
3 variables. How many integers can I store though?
A lot. There's like
5, 7, right?
7.
As we get 5 plus 1 plus 1. Right? I try not to do hard math. We could do
You
That's
surpassed
7
my
again,
level.
like the riddle.
Exactly. It's just gonna show up all over the place. That makes sense? Right? You can declare them in line. A lot of times you don't, but there's nothing wrong with it. We talked about this a little bit. I'll just talk about it again. Square brackets mean different things depending on context, right? On declaration, creation of the array means size. After that, it means what index are you trying to access. All right? Okay, good. The cool thing about arrays is that the index, the thing in the square brackets, does not have to be a literal value, right? So for all my examples are like score bracket 4, score bracket 3. But it can be score bracket n, or x, or I, or 2 plus 3. It can be all those things, which allows us to manipulate the index of the array, which we're going to see. We're going to use that with for loops to get to every element.
I was just thinking that.
Right? So you can do score n plus 1, that kind of stuff. So let's look at this. Let's just assume I have this score array, right, of size 5. Right? First box is located at what index? Last box at index?
4.
Good, size minus 1. Right? Remember that?
Yeah.
So I create one variable, but I really get 5 spots to store those variables. Good so far?
Yeah.
Right? And what I'm saying is that you can use a for loop to start at the first box, move to the next one, the next one, the next one, and the last one. All right? And because I know how many times I want to visit, right? When you know how many times you want to loop, you use a
For loop.
Right? And so that's where the for loop comes in. You'll notice my for loop starts at what?
0.
Why 0 and not 1?
Because the array starts at 0?
Because the array starts at 0, right? And so the index is going to correspond, right? Think of these numbers. These numbers are going to correspond to I. So every time I hits one of these numbers, you're going to be at that particular box. Does that make sense? Right?
Because I will have a value after each iteration.
Right. So let's look at, right, I just built it in. Let's just assume my array has values. Right? I starts at what?
0.
0. Is 0 less than 5?
Yes.
Yes. Right, so we go into our for loop. And the for loop says, don't see out I, which would be 0, but see out what?
The
Score
index
bracket I.
where I is.
Exactly, right? So the score, kind of like an object, right? Score says go to that variable.
Oh.
The bracket 0 says go to that element
I
of
got it
that
now.
variable. Right, so score bracket 0's value is?
Ocho.
And what do we output?
8.
And then the for loop ends, right? That iteration of the for loop. So we go back to I++, right? So I becomes
1.
good. Is 1 less than 5?
Heck yeah.
Right? So now we see out score not at 0, but score at
1.
1. And score at 1 is?
3.
Right? And then I becomes?
2.
So we see out score at 2, which is?
7.
And then I becomes?
3.
Right? Everyone kind of good with this? I becomes 4. Is 4 less than 5?
Mhm.
Yeah. So we output score bracket 4, which is?
2.
2. And then I becomes what?
5.
Is 5 less than 5?
No.
No, so the for loop ends. And you'll notice that in that for loop, did I visit every element of the array?
Yeah.
Yeah. Right?
Kind of.
So if you want to visit every element of the array, you always, all right, so I'm going to change, you always start your for loop at 0, and you always say that I less than, that says 5, what do I mean? The number, right, the number of elements in that array, right? Because score was of size 5.
As long as you're starting at 0.
Huh?
As long as you're starting your.
As long as you start at 0. But if you don't start at 0, then let's say you started at 1, instead of I, every time you'd have to say I minus 1. Because I would be 1, but to get to the first element, it's actually 0. And that sounds like a thing. All right? So now with for loops, and I tried to say that when I introduced for loops, get used to starting counting at 0. 0 less than size, right? That size can change. Right? Everyone good so far? Why a for loop works? Right? You're gonna run a lot of for loops today. You're gonna create arrays and then you're gonna write for loops because, right, this for loop works for an array of size 5, but if my array was of size 100, I change that 5 to 100 and will it output all 100 values?
No.
Yes, it will, right? Because now it will loop from 0 to 99. All the indices of an array of size 100 is 0 through 99. Right? So the same for loop will work on a small array and it'll work on a what?
Ginormous.
Which is really nice as opposed to creating 5 variables or 100 variables and writing these really long CL schemas. No, not yet. You gotta wait. You gotta stay till the end of the class.
Will we be storing values in those indexes now?
Yeah. Right, so I'll give you all the elements. So let me do an example, right? So you can see kind of what's happening.
Do you secretly hate all our questions?
No. No. The more questions to an extent, the better the class is. Right? This is how I normally think it. Lots of students for a reason don't like to ask questions, but a lot of times the questions that other students ask are like, oh, that's a question I had, but they're just too scared. Maybe it's not scared, but just, I didn't really ask any questions, I just sat in the back.
And now you don't even teach Business 18.
Making a lot of money out there. All right, let's look at this. Arrays are built in to C++, so there's no special includes or anything like that. They are basically a fundamental thing of pretty much every programming language, right? And so let's create an array to handle, right, my scores. Right, so I'm going to say int score bracket 5, right? And then, right, just kind of going off our example that we did, I'm going to create a variable to hold the highest value. So that way I can create my array and find the highest value.
Do you also have to declare I? Or?
I'll declare it in my loop. I know my example online declares it there, but I'm going to declare it somewhere.
I've never seen it like that. That's why I asked. Because usually you just do it in the loop.
Right. Okay.
Oh, because he did it there, he doesn't have to
enter 5 scores. Right. We'll do a new line here. Right. And so before my loop, I'm actually going to get the first score, and I'll try to explain why that is. Let's look at this. Right. This right here. We're all good with the CSCI statement, right? Enter 5 scores. That's what the user says. CN says get from the user, right? The CN greater than says get from the user. What's on the right side is where do we store it, right? Are we good with that? Normally it's a variable. Well, now it's an array at a location, which also basically is a what? A variable. So this says get from the user, whatever you get from the user, store it in the score array at location 0.
Variable inception.
So it's going to override the 8.
So that input would be 8 or it would be 0.
Their input would be whatever they want to give me, but it's going to go over the place of this, right?
Do you have to ask that for each index?
Good question. What do you think an integer array starts with values? Good, right? Because it's an integer. So all 5 spots actually start with garbage, right? So if I wanted to get 5 values, I would have to have how many CN statements?
5.
5.
Okay.
Right? Now I showed you that we can loop to do that.
Yeah.
I'm going to tell you why I didn't loop for the first one. Yes, that's the next slide.
Whoop, whoop.
Good question. You guys are asking questions about stuff we're going to do today, which I'm all for. All right, there's C score, right? The reason that I got the score like this is because if I'm calculating the largest value, if I get one value, the largest value is what? That value. Right? If you're an only child, you're your parent's favorite child. You're also their what? Least favorite child, right? So depending on the day, you might think you're one or the other. Right? So I'm going to say highest equals score bracket 0.
Oh, that way you're starting with your jumping around comparison.
So really I have a score array, right? And I also have a variable called highest. Right? They all start with garbage. Right? But on line 15, I say get from the user a value, store it at score bracket 0. Right? So if you gave me 8, it would put 8 at score bracket 0 because that's what my CN statement's putting it in.
And then that's also going to be.
And then I'm going to say score bracket 0 gets assigned to. Make sense?
Yeah.
Right? That's the only reason why I'm doing that outside of a for loop is because the first one I just want to store. Right? Because it is the highest value. Right? Now, right, I've gotten one value, so how many other values do I need to get?
We need to get 4
4,
more.
right? And I already got the value located at index
0.
0, right? So the next one's located at index what? 1. So usually, you're not going to start your for loops at 1, but I am for this one because
Int I equals 1.
Because I've already gotten 1 for 0. If I started at 0, it would overwrite my 8 with something else, and I don't want that.
And then you'd stay at 4, right?
Right? I less than what?
4.
No, 5. Always less than size.
Oh, okay. Got it.
Right? Because now I corresponds to your index, not just how many times you're looping. Right? So you gotta remember that. And then, do I want to go to every single one?
Yeah.
So I plus plus. If you wanted to go to every other one, you could say like I plus equals 2. Or if you want to every third one, you could do I plus equals 3. I don't know why you'd want to do that, but you could. No, because those are bitwise shifts. We're not shifting bits. We're going to I plus plus. And then very similar to what I did up there, I'm going to CN, right? I'm going to CN into my score array. What am I going to put in my square brackets?
1.
I heard a 1 or I heard an I.
Dang it. I think it's I.
Why is it I?
Because that's
Because it'll be 1 the first
corresponding-
time,
Yeah.
but then it'll be what the next time?
2.
2 and 3 and 4, right? This is how I try to explain it. In your for loop, what value is changing? Whose value is changing? I's value is changing.
Yeah.
So if you want to use the value that's changing, right, then that's what you're going to put in your square bracket. The first iteration, you'll be here. The next iteration, you'll be where? Here, and then here, and then here. But then I would start here. But I've already gotten that done.
So you.
If I started at 0, I would have to say I plus 1 in the square bracket, which is the
I think what's tricking me is that I'm worried that the user is going to enter 198, and then that's going to obviously be greater than 5 and then stop running, but that's not what's happening because that's its own variable going
right, it's
to
its
the
own
index.
variable, right? I's not going to mess up.
Right.
So you don't want to use I to store anything in your loop, right?
Right.
It's just for counting.
And that's what my initial was like, oh,
So now, right, I said I is for iterator. You can also now start thinking of I as index, right? I is the iterator, and for loops with arrays, it's also the index of what you're trying to do. Okay? Now this isn't the end because, right, we said, look at the first value, right? That's the highest value. And then we said for the next value, compare it to the highest value, right? And see if it's bigger. Can we go with that?
Yeah.
So if I'm going to do comparisons, what do I need?
if
Good, right? If statement, right? If what?
if score bracket I is is the greater than, yeah.
Right? If the new, right, score bracket I, right, and score bracket I is basically saying the new score you're getting from the user, if it's bigger than the highest value I've ever seen, then what?
Then score bracket I equals highest.
Not I, right? If you did I, it would just equal 1 or 2 or 3, right? So in your loop, you almost are always saying score, right, array bracket I.
And that will ensure that it's comparing it to everything before it decides that.
Because basically, I is 1 right now, so we're going to get a value for 1. If it's bigger than the highest value, then it becomes the highest value. If it's not, it doesn't. But then I becomes what? 2. We do the same thing over and over and over.
But what if the initialized score ended up being the highest and it never checked?
Well, it checks every time.
Oh, because
It
highest.
just won't change.
Okay.
Right? So the if statement will always be false, and so it'll never make it.
Now it makes more sense why you gave highest at least one value to check with.
Right. Because, okay, so this is what sometimes students do with this algorithm. They start highest at 0, right? And then they say, okay, compare everything to that, and if it's bigger, then it's bigger, right? Which works, except for what?
If it's 0, if it's not.
If all values are smaller than 0.
Yeah.
Which could happen if all the values were what? Negative. Right? Because all of a sudden the highest value in your array is 0, which doesn't even exist in your array. Right? So you don't ever want to just put an artificial value in there. You want to work with the values you already have, which is why we just make the first one be that. Make sense?
Yeah.
Right? After this loop, do I have the highest value computed?
Yes.
Yes.
Yes, right? So can I see out it?
Yes.
Mhm.
See out, right? The highest score, right, is, and then we can output, right, highest.
You also want
I really need to win.
That's what that's.
Flute.
The line I see is in the loop, so the loop has the entire thing. All right, so there's my highest score, right, and then we can say, see out, right, the scores were, right, and look at that. Now, if I want to output all the scores in my array, what do I need? Good, a for loop, right? What you're going to find out is you're going to run a lot of for loops.
Which are amazing.
Right? So here's my for loop. My for loop should start anti at what?
0.
Right, the first element of my array, I less than the size, which in this case happens to be 5. I plus plus, good. And now, right, basically, anytime I write a loop with arrays, it's what do I want to do with the array name bracket I. Right, not array name bracket 0 or 1, but I, because I will be 0 and 1 and 2 and 3. In this case, I'm outputting, right? So what I want to do with score bracket I?
See out it.
See out it, right? So we're going to say see out score bracket I, right? And then we're going to say off by, I'm going to bring it down, right? And then we can say like score or highest minus score bracket I. Right? So this will give you all of your scores and tell you how much you are off from the high score. All right? So you can be really happy about, oh, I was only 1 off. I'm really sad that you were like 95.
Why am I missing this point?
Does that make sense what I did there? All right.
That's kind of cool, actually.
Basically, one loop to fill it up and one loop to what? Output it. Right? Notice they're their own loops. They're not inside of each other. They're just their own loops. One loop, go element by element, fill it up. One loop, go element by element, and what? Output it. Right, we look for typos? Now that I wrote way too many lines of code.
I don't see any typos.
Well, I compiled. Enter 5 scores, ready? 8, 5, 9, 3, and 2. Right, the high score is what?
9.
Is that the high score?
Yay.
Sweet. 8 was off by 1, 5 was off by 4, 9 was off by 0, 3 was off by 6, and 2 was off by 7. Is that all 5 values outputted?
Mm-hmm.
Yeah.
So it seems like we did it correctly?
How is it, so, okay, I get the math, but how is it like that as the for loop's going through, at some point, its highest value was 8,
Right.
right?
But this for loop
So how does it know that it's off by the highest one
Because this
until
for
it's
loop was
finished?
written after my first for loop that calculated that.
Okay, so it did all of that, and then you reap the benefits of that
Yeah.
with the
Right, because code's sequential, right? So it looped the first for loop, got all the inputs, found the highest value, and then from here on out, the highest value is 9, not what it was.
Right. Sorry, I just had to make
Gotcha.
sure.
Good with that? All right, I'm going to do something that's in my slides, but I'm going to talk about it here. Okay? I want us to think about the fact, everyone good that 5 shows up there?
Yeah.
But it also shows up where?
In the for loop.
Right? And where else? In that for loop? Right? When a number shows up multiple places in your program, it all means the same thing, right? That number 5 means what?
Iterations.
Well, yeah,
Or size.
but really the number of elements in my array, right? The size of my array. Everyone good with that? Right? If a number shows up a lot of times, what should we use instead of the number? A constant, right? Constants come in, right, to name values. Right, I'm going to show you why that would be useful. If, right, instead of 5 scores, right, let's get you in a class with only 5 quiz scores, I don't know, right? Let's say if it was 10, right now, what would I have to do? I'd have to change this 5 to a what? And then the 5 above that to a 10. And when I created the array, I have to change it to a what? 10. But instead, right, you guys said I can make a what? A constant, right? So I say constant, right, k size, right? And we can say that's 10, right? And then if I wrote my code correctly, right, I could have said instead of 5, I could have said what?
K size.
K size, right? And down here, instead of saying 5, I could have said what?
K sizzle.
Right? And just for the sake of redundancy, instead of saying 5 here, I could have said K size. Okay? Now this is the cool thing about arrays. I just made my array size 10 as opposed to size 5. Did I have to change any other code?
No.
No, because the for loops take care of how many times you want to loop, right? So it doesn't matter if there's 10 or 5 or 2 or 20, the for loops look exactly the same. Right? And so all it means now is I have to type one. Right? So we get our 1, 2, 3, 4, 5.
You just have to fix
4,
your
3.
5 and your C out.
Oh yeah, I did, huh? 0, right? The highest score is 5, the scores were, right? And so I could have fixed that too, right? Chris is saying I still said enter 5 scores, but I could have done what? Enter, right?
K size.
K size. I forgot 5 showed up the 4th one. And now when I run it, it should say enter 10 scores, right?
Sick.
So now if I wanted 100 scores, right, because I like to just waste your lives, 1,000 scores.
And now it's all fixed. Just
Right,
for
I do that,
one
and
thing.
now it says enter how many scores. Alright, so you guys just sit here while I do this. But would it work?
Hell yeah.
Yeah, it would work, right? Pretty cool, right? You don't believe me?
Oh my god.
I said something that said, hey, we're done with input. Oh,
You are off by
I gave it
negative
bad
6
input.
million.
If you use CN and you don't give it an integer, you're asking for an integer, CN breaks.
You are 57 off from 2.1 trillion.
There's all the garbage values.
Fragile life.
Right? Someone got this score.
Oh my god. He's still 76 off.
It wasn't Daniel.
All right. Questions? Does this make sense a little bit?
Oh, no. Yeah, but
Still 76 off though.
Right. So if I was inputting the scores of everyone in this class, I would make an array of structure, where the structure had internally a string for name and a int for first one. So you wouldn't name each element, but each element would have it. Which then makes your syntax look crazy, because then it's not score bracket I, it's score bracket I dot name, or score bracket I dot now. All right. Good question. All right. I did that, so my lecture will be a little bit shorter, right? So we're going to initialize arrays, and we're going to use what? Constants. But now you guys are great with that. You understand why, right? So let's look at initialization, which is just one slide. And then we'll go from there. So you can initialize arrays on declaration, okay? And that's very important. You can only initialize the array when you declare it. So you can't use this curly brace syntax we're going to learn later on. Only on what? Declaration, right? So here, int children bracket 3 equals 2, 12, 1, right? Which that's the same syntax we use for structures. We did the same thing to initialize structures on creation as well, right? And what this basically says is that this array is of size 3, and 2 is that element what? 0, 1, and 2, right? So it's actually giving all of them values so they're not garbage.
You declare it, you like do those top three and big dot space and big.
You mean like this?
Yeah.
Yeah. Yeah. And it's smart enough, compiler's smart enough to say, hey, you gave me 3 values, so make the array size 3. The only time you don't have to get an array of size is when you initialize. And then you can say, yeah, that's good. You just asking that because it's on the left? Maybe.
No, he doesn't have it up. Oh, he is.
Note that this line here, right? That's why I told you questions are good for the whole class, right? This one here, right, is the same as doing those 4 lines of code. You can decide which of those 2 you would rather do, right? But they both mean the same thing, right? This says create an array. All the elements are garbage, and now start doing
I like that one. That's like
the array.
JavaScript too.
This says on creation of your array,
I like
give the
seeing it
elements
all.
these values. Right, so your array actually never starts with code.
I like it that way the best.
And yeah, right? I don't know why you write 4 lines of code, right? Imagine if your array was of size 10, right? Then you have to do 11 lines of code.
Bar.
Or 1 line of code. Your choice. If you do that though, you don't have to give a size. Right? Which I think is question 2B or something.
Can you give it a size but
Ooh,
put
good question.
extra
If
in
the
the array?
size of your array does not match the size, which also is a question.
I just asked that.
Right? It depends on which way you're going, right? If this was a 5, then it would put the first 3 elements as those values, and the last 2 elements would be garbage. If it was a 2, then you're running into problems. So you're going off that cliff we were talking about. Okay?
Yay!
You don't want to go off.
I want the computer to freak out.
Yeah, so, yeah, it looks like you ran off a cliff. You just say that.
100 values and 101 elements.
It'll store the first ones in like elements 0, 1, and 2, and then whatever the elements are left, they'll all be garbage. All right. We're good with why we would use constants?
Yeah.
Right? I mean,
Constants are
it's
now
better
our friend.
for you, right? If you need to change your code, would you like to change your code in 1 spot or like 100 spots?
Yes.
Right, exactly. The ones.
Odds are, by the time we realize we need a constant, we'll have to do the 100 spots anyways.
Hopefully you'll only have to do like the 3 spots. You're like, hey, this number, I keep using the size all over the place. Really what I'm trying to say is when you use arrays, you use size all over the place. So just heed my warning and make it a constant. Right?
That's no fun.
Yeah, right. If you're paid by the hour, then don't, right? Or if you want that job security, right? Try to make your code as convoluted as possible. No one else can understand what it is. You'll never get another job, but as long as your company doesn't go under, you might keep your job for forever.
Forever.
So there's like a fine line there.
Sounds awful.
Yeah, that sounds awful. Okay, this is a big key. You cannot create an array with a regular integer variable. It has to be a constant. And what I really mean by that is that the compiler needs to know the size of your array at compile time, not at runtime. Okay? When you make a constant, the compiler knows that value is not going to change. It's always this value. When you create a variable, that value could theoretically be anything, right? It's a variable. Right? And so the compiler needs to know. I will teach you later this semester, right, how to make ones that are of any size, but for now, they're always fixed size, and you have to know them at compile time.
Oh.
Right now. So that you can't do this. You can't say, which you're like, why can't I do this? This sounds great, right? Enter a number, tell me how many children you have, input the children, right? And then you can create an array of that size, right? Which sounds really useful, but the syntax in C++ to do that might make us cry at this point. So we're not gonna go there. Right? It will make you cry. When you go to algorithms 2, it will make you cry even more. No, it's just because it has to know the size and the way that it creates it. It can't do it this way. It has to be dynamic. When you make things dynamic in C++, you have to introduce pointers, and pointers make you clear there. Okay. Yeah, right? The book has them. You knew that they're going to show up eventually. This semester, they'll show up just enough for
JavaScript had that too.
Next
for a
semester,
second.
they'll make you try. I remember, I think you asked, like, can you make the array bigger? With dynamic arrays, you can, but that algorithm also.
Like what I want to know is like the case size could be 10, but say you have multiple teachers trying to use that program and all their classes have 21, 32.
Right.
Can it be pushed or popped to like extend?
No,
No?
not with what we're making. You'd have to make it dynamic.
Okay.
And so,
Which is what you were just talking about. Okay.
He just keeps
you can do
going
it.
after
Just,
that.
we need more syntax.
Yeah, but it's useful.
All right, let's look at this example. This is our last code example today. Well, this would just be a constant integer, which means you couldn't do it. Or it could be int star children, and then children equals new and bracket.
Ew,
Children
equals new.
All right, all that work. Let's get rid of it.
Yo!
Oh, and I do that one more time today too. It's like a cool job. We could say
Are we
something
doing-
like string children.
Are we initializing a
String
constant
children.
array?
What?
What are we?
Yeah, we're going to initialize constant array, although I'm not going to write all that because we already did the constant.
No, I just want to make sure I'm looking at it.
So here we have John, and here we have James. Right? And we can see out, right, oldest child is, right, children, bracket 0, right? And I'm going to add something here. I'm going to say const int k size equals 2. Right, so I'm going to say the oldest child is that, and then I'm going to say the youngest child is not at 1, but really at k size minus 1.
So would you need to fix the oldest child as well?
No, because basically I'm saying the first child in the array is always the oldest child, and the first child will always be at location 0, right?
Okay.
I'm saying the youngest child will always be the last child in the array, which is always that size. These happen because there's only 2 of them that are next. Everyone good with that?
I don't like that, but okay.
I think it would make more sense.
Right? We're gonna, well, I was gonna just change it in a minute.
Can you just add like Jumbo or
Right,
something?
so there's Jane, and now we have Jumbo.
Wonder why he's named Jumbo.
I said Jumbo, but it's okay.
I was going with the J's, right?
Hey, that's fine.
We have Jackie.
What about Jake?
Right, if I just ran this right now, it wouldn't work right because it would say the younger child is Jane. Anyone know why it doesn't work right? Because case size is still 2. Change that to 4, right again. Right, and now John is the oldest and Jackie is.
But that's because the John and Jane they don't have values yet.
There was a famous John and Jackie. No, case size is a constant, right? So we have to give it a value at creation. It won't know how big the array is.
So in
Lots of
that,
programming languages, they know how big the array is, but not in C++. Not with our basic array. So you could like get the size of it, but not in C++.
how does the string John have a value to tell it that it's greater than Jumbo or Jackie?
Well, when it creates it, it just puts John as the first element, so location 0, Jane at location 1, Jumbo at location 2, and Jackie at location 3.
So all you said was move one index and say that that's the youngest child.
So I'm putting my own parameters on it in a sense.
Okay.
Right? I could say maybe the first one's the youngest and the last one's the youngest, right? So long as you're consistent in what you code, then it doesn't really matter.
So I guess what I'm looking at is I'm expecting there to be a for loop and giving Jane and
But they don't
Jumbo
have ages,
and ages. That's what I'm saying. I'm saying that I'm assuming that they have ages. Okay.
If I was going to give them ages, I would create a structure, a person structure, give them a name, an age, maybe other stuff, I don't know. Gender, I don't know.
Favorite hobby?
You could. No, because case has a constant. You can't change it. Can't change it. You're always pretty much going to know how big. You're either always going to know how big the array is, or when you get to dynamic arrays, you're going to ask the user how big. So you'll always have a variable that will store. So you don't need to know. All right. Pay attention to this because this is on your lab as well. All right. I'm going to teach you how to comma separate an array. Okay. We do that a lot with arrays. All right. My other example, we did all the scores each on their own line, but a lot of times you want to put like name, comma, next name, comma, next name. Does that make sense? Right? So, right? How do I get every element in an array? What do I use? Good. And start I at what?
0.
All right. And I goes less than what?
The size.
The size, right? Which I conveniently have, right? I less than what?
4. Or
Case size. I want to use my constant because I have it. And then I what?
Plus plus.
Plus plus. And then what am I going to see out? Not case size, but the name of my array, right? Children at location I, right? Bracket I. Right, if I want them comma separated, then what do I want to put after them? A comma. Right, I'm going to add a space, so it's a little bit nicer. All right, you ready to see this? There's, well, here, let's add it in line.
Jackie Jones.
That looks terrible, right?
Something's wrong there.
Add it in line. There we go. That'll make it a little bit better. Right? Oldest child's John, youngest child's Jackie, and we got John, comma, Jane, comma, Jumbo, comma, Jackie, and then what do we have?
Comma.
Comma. Is that trailing comma? That's pesky.
Oh man.
Right? Do we want a trailing comma?
No.
No, right? Because that just looks ugly. Right? Anyone have ideas on how to get rid of the trailing comma?
You could add the comma to the name in the array and then just
But I don't want to.
period at the end.
I don't want to. No. All right, here, I'll ask the question that will lead you. I'm going to help lead you to the answer. Right? When do we not want a comma?
At the end of
At
something.
the last one, right? So what we're really talking about is the last iteration.
Oh, move where the
of
comma
my for loop,
is.
right?
Move where the comma is in your C app.
Yeah, that still won't all the way work.
Why don't we just do eyes less than case size minus 1?
All right, there we go. Did you guys hear that? I less than case size what? Minus 1. If I run that, what do I get? I get John, Jane, and Jumbo. And who am I missing?
Jackie.
I'm missing Jackie, right? But we're on the right track.
So then you can just
Right,
see
because I
out.
want a comma after every element but the what? Last one. The last one's always located at?
Yeah.
What is that location? Size -1. K size -1 though, right? -1. Don't do K size, that's off the cliff. We're gonna find out what that is. Right? Just throw Jackie at the end, right? You don't get a comma, Jackie, right? So in the loop, we output every element but the what? Last one. And then at the end, who do I output? Jackie, right? So I see out, right, children at what?
K size -1.
You want to go off the cliff? Why not? We're going to do it. With strings, it's not that big of a deal. It probably won't even output anything. But it might. Hopefully it's not. Oh, yeah.
Oh.
Hold you not go off the cliff.
Oh my God. You just hacked yourself.
What the heck? A wild balloon looking person.
I love that John, Jane, Jumbo, and Jack actually are in there, right?
A wild fellow
took
too.
place in memory and translated what was there into a string.
HHLDAH9AA. What's that? It was like a wobble with a snap.
I wasn't expecting it to be actually that
That was pretty
hilarious.
cool.
That was
Yeah.
pretty
I wasn't
bad.
expecting anything. Right, okay, I did -1. Did I go off the cliff? No, right? John, Jane, Jumbo, Jackie with no comma at the end.
Can I put a period?
Yeah, you want? You want a period?
But like you could have fixed that with just in your quotes in your array, putting the commas if you wanted
But
them.
your array does not always hold strings. Right? So if
Fair.
this was a list of integers,
That's fair.
I could still output them comma separated, which you're gonna have to do in today's lab. Right? So this is the way to do it.
My answer wasn't wrong for this though.
For this. Although then John's name's really John, comma, right? Maybe that's what's on his birth certificate.
What?
And every time you have a new child, you have to like update their name and be like, nope, you're not the period one anymore, you're not the youngest. Right? How about can we do an exclamation point? I feel like you guys are a little alike.
Not in line?
What?
Yeah.
I can do whatever I want.
But
And
When you add a value to an array that doesn't exist, that happens.
Yeah.
you put the and in inside, then we'll say John and Jane
You have
and
to have a
Jumbo.
space. That's what
I mean, I got no strings to get at.
Okay.
Who cares?
This isn't an English class.
Without the comma?
And all you do is look at his slides and find all his things.
It's not,
Does it make
it's
sense a
not
little
an
bit, comma
English class.
separated? My example does it a little bit differently, right? The other way you can look at it is you could write an if statement in the loop, and you only add a comment if I is less than size -1.
That's actually a cool way to do.
So that works pretty well, right? I can show you that because that's what I have here. Right, the other way that you could write it, which also works. I like this because there's no if statement, it's a little bit more succinct, but that's the other way you could do it. Right, you look through the whole thing, you always output the child's name, but if you're not at the last one, if I is less than the last index, then we add a comma.
That's what I was thinking.
So you can think of it both ways, they both do the same thing, they both work. I don't care which way you do.
That's like your way of avoiding the like, if it's not less than, like the.
But I'm just not making a decision, which technically is faster, right? It's more efficient to not have the computer make a decision. I mean, we're talking about like nanoseconds.
Input lag.
It doesn't really matter, but it matters to some people. Good? All right. You guys always make me talk longer. My other class, we were done. 45 minutes in, we were done.
Yeah, but they probably
They
don't
didn't
even
say a
ask
single
any
word to me.
questions.
I think half the class
I just kind of
was
sat
asleep.
there.
All right. Well, let's talk about the clip. All right. So let's talk about arrays and memory. Something that it's kind of funny. We don't really talk about it a lot. It's like this hush hush thing that all your variables are stored in memory, right? That memory is a real thing. Like there's physical memory in your computer that's like storing your ones and zeros, right? We just don't talk about it because we don't really need to know about it. But for arrays, it's important for us to realize that arrays are stored in memory like other variables, and how they're stored in memory kind of affects the way that we use them.
That's like solid state drives and stuff.
Yeah. Most of these guys hold memory, right? We're talking about RAM really, like, right? It's all temporary memory. It's really small. So let's assume we have the following thing, right? I can ask you some questions on this, like, what's the name of my array? A. How many integers does it hold?
6.
6, right? This is base type is int as well. Everyone good with that? The last element's A bracket.
5.
First element's A bracket.
0.
Good, right? You guys are great.
You're welcome,
You guys are
guys.
paying attention. Right? I know it is, right? You're like,
Carries.
okay, this is the key thing with arrays. All elements are placed in adjacent memory locations. Right? Sometimes we call it
Next to
contiguous
each other.
memory. So the first element is in memory, and the next element is right next to it. And the next element is what?
Right next to
Right
it.
next to it, okay? And because of this,
Like a blockchain.
C++ only has to remember where the first one is because then it can figure it out based on that first one, right? It'd be like if you live in one of those cul-de-sacs where like house is like house 1, house 2, house 3, house 4. Right? You guys know what I'm talking about here?
That way you know.
Sometimes we wish we lived in one of those cul-de-sacs. But we
Bless
don't.
you.
Right? If you're at house 1 and you say you need to get to house 4, right? All you have to do is what? Go to house 1 and then go down 3 more houses and you'll get at what? House 4. Same thing happens in arrays. If you're at index 0, the first index, if I just add 4 memory addresses, then I'm going to be at index 4. Right, 4 I'll be at.
So I know that there will be a way of separating.
You want to separate, they're still together. The pointer would allow you to remember the memory. But we don't need it. Alright, so let's look at this. So the computer, C++, is only going to remember where the first address is, and it's just going to calculate where all the other things are based off of that. Right, so here's my ugly picture. I have a better one in a minute, but that's my ugly one. Right, so you'll notice I have my int A6, right? It's of size 6, so it takes up 6 spots. Right, you'll notice that each spot, though, takes up 2 rectangles. Right, basically saying integers take up 2 bytes as opposed to 1 byte. Right, and so technically it takes up 12 bytes of memory because each integer takes up 1 or 2 bytes of memory.
My computer ran out of memory.
Interpreting the picture. So all C++ remembers basically is this 1023. It remembers where the array starts because since everything's in contiguous memory, it can figure out where it is. So what this red says is that if I want to get to A bracket 3, right, C++ says, okay, let's go to A bracket 0, okay, and let's go 3 integers down. And because an integer takes up 2 bytes, we take 3, we multiply it by 2, and we get
6.
6. We take 6 and we add 1023 to it, we get 1029, which happens to be, right, 1029 where what? A3 starts. Yes, but we don't have to know where it begins. And because we made them integers, C++ knows how to interpret all the bits and bytes. Does that make sense? Right? The problem arises when I say A bracket 6, right? Outside of my array off the cliff. Right? Guess what? C++ just does the same exact thing. Take 6, multiply it by 2, what do you get? 12. We add it to 1023 and we get what? 1035. Right? Which is where? Right here. Everyone good that right here is beyond my array?
It's Lake Placid.
But C++ doesn't care. You can add as many memory addresses as you want. You can go wherever you want. All right? But as we saw in our example, do bad things happen?
Oh, yeah.
Yeah, right? And they happen in 2 different ways, and we're going to talk about them. Does that make sense? Right? Why you don't want to go off the cliff? Because you're accessing memory that is not part of your array. You're accessing memory of something else. Right? In this example, you're actually accessing the memory of some variable named stuff. No guarantee that it's the next variable, right? But you're accessing memory that's really not part of your array.
Could that be like on a different window? Like a program in a different window?
So, remember I was going to teach you ways to crash your program? Right? More ways to crash your program? Right? This is one way, because if you go a little bit off the cliff, you're probably accessing the memory in your program. If you go way off the cliff, you're trying to access memory in someone else's program, which always makes your program crash. That's why there's operating systems. One of the things they do is they protect your program from others. So you won't be able to go look at the memory in someone else's program. You're stuck in your program.
Boring.
Yeah, I know, right?
Unless you're a hacker.
limited memory, but a bunch of arrays, you might technically have enough memory in each range.
Try a program that keeps using up the RAM.
You're using up the RAM.
No, like make a program that keeps making arrays and just watch your RAM usage just keep rising. Just make it go
You
bottleneck.
hope that you don't. If you run out of memory, then when you're working on something that has such a finite amount of memory that you have to pay attention to it, you'll do a bunch of other things to make everything as small. Because if you think about it, a Boolean is 1 byte, which is 8 bits, 8 ones and zeros, but a Boolean only needs how many ones and zeros? 1, right? So there's ways of kind of smashing it, smushing it. So that error is called index out of range, right? Going off the cliff is because you're going to an index that is out of range of your array, right? The last index you should always go to is size minus 1, right? Don't go size or more, always size minus 1. So if I have an array int A4 and I access A bracket 4, have I gone out of range? Yes. Right? And so in this example, 2 different ways that it could be, right? When you reference A bracket 4, basically you're getting some other value, right? Which, if it's a value that's unknown, we call it garbage, right? So when you reference it, you're going to get garbage values. Now, if you set it, it's even worse, because you're not getting garbage values, but you're overwriting good values, right, with some other random value, right? And so that's probably worse, right? So accessing is bad, but really, right, storing is worse. Assignment is worse. Right. No. The protection is me teaching you not to do that. That's the protection.
There's no like end if.
No, right? Eventually we'll either use something or create something that will do that check for us. But for now, we just have to be aware of it. You should always be aware. So this is worse. This, more often than this, will actually crash your program. Just to show, right, the other picture, right? Here I have my array of size 3, a variable stuff, a variable more stuff, right? Those have values. So when I see out A bracket 4, what do I expect the output to be?
You're expecting the or sign.
No. Because look, every integer takes up how many spots?
Oh, 2.
2. So I take 2 times 4 and I get 8. 8 plus 1 is 9. So what do I get for output? More stuff, 2. Right? And when I say A bracket 4 equals 100, then more stuff becomes what? 100, right? Both of those being bad. The only reason I get a 2 is because it was an integer, right? If that was a double, then it wouldn't work. I mean, it would work, but you get a weird garbage value because it's going to try to interpret the bits not as a double, but as a what? As an integer. Make sense? Yeah. All right. Now we go with arrays. They group values together of the same type. That's kind of the big thing, right? Grouping values together of the same type. We declare them with square brackets, right? Anytime you use arrays, you use square brackets. Anytime you use functions, you use what? Parentheses. So some of these symbols will be visual clues of what the heck you're doing, right? Arrays start at index location. Good. What kind of loops do we use with them? For loops. Right? Curly braces are used to initialize if you want, comma separated. And a semicolon after, right? Remember, there's only a couple places you have a semicolon after curly. One, initialization syntax for structures or arrays. And then the only other place is your class declaration. Not function definitions, right? But the class declaration, I think above it. Constants we should use, right? And arrays block out a chunk of memory, right? Because every element is stored in contiguous or adjacent.
Just go and search for
No, it'll basically you have this thing called the stack. And so the stack is all this memory that's been reserved, and so things just slowly go on the stack, one after the next. Which is why in my example, right, you got like variables right after zero. So there's not these big gaps. And when you get into dynamic memory, you take things from the heap. The heap's just a heap of memory, and you just kind of reach in and whatever you get or whatever. All right, I think that's it. Oh yeah, don't go off the cliff, right? Don't go off. Sound good?
Yeah.
Let's look at today's lab. which I've given you some answers, right? Because you guys asked them. Now what my lectures are going to turn into, you're just going to ask what the answers are.
I mean, now that you said it.
Right? You're like, oh, why haven't we been doing that all semester long? Question 1 should be pretty easy, right? I give you the array declaration. You need to tell me, right, what is what. Right, so that one should be pretty easy. I don't really want to talk about it. 2, are there any errors? If so, right, say there's an error, right, A, B, C, or D. The hint I'll give you is 2 of them are errors and 2 of them are not. So, now it's 50-50.
Incredibly easy.
What is the output of the following? So 3, 4, and 5 says what is the output, right? Which means you can check your answer, right? The goal is for you not to just paste it in, because anyone can just paste it in and run it, right? Can you figure out what the answer is, and then you can check your answer and see what the right answer is. And then question 6, right, is you're going to write a program that gets 10 values in, and then outputs all the values comma separated. So you need one for loop to get 10 inputs, and then you need a whole different for loop to comma separate them. Do we write a comma separated for loop now? Yeah, then write a for loop to get values. Yeah, so you just have to put those two together in a program. Right? Can we do that?
Yeah.
All right, you get all that done? Then keep filling out assignment 3B. Okay? Because it's due a week from when? Today. And I don't know if you realize, but when you email me at 10 o'clock the night that it's due, I normally don't get back to you. Right? So, I don't think they're right. They're like, why are you talking about it? She would have made like 11:30. I had a problem with it. I'm asleep. Leave me alone.
30.
Questions? We good? All right, I'm done talking. You guys always ruin my voice for the next class. I'm like, you're quiet in that class. Yeah, who cares? Who cares about that class?
That's what they get for scheduling away this to the day. Except for Jared. Jared's cool. You work for Jared, don't you?
I just saw him today.
He works here.
No.
Yeah, he was working at the sandwich place, and I got a sandwich, and I was talking to him.
So the unit test is it's basically taking value.
You what?
From my games.
You did get You let them fight each other in the rocket? Oh, nice.
So like the unit test will be a today. You'll
You
use that
were
here.
gonna Oh, you were trying to do the challenge.
It's like 5 when 5.
Like you weren't going into that match expecting anything other than to get your battle pass up. Great.
Yeah, totally.
This. Is 1D infinite?
I think what you're asking that.
No, for D.
Size is fine.
Because I feel like, I don't even know if I'm getting this right. So I did what
Well, now, yeah, what's going to block it?
No, the boxes were still like, Because it's equal to parents, so it's gonna be that big a spot.
You can do it.
everything is like, I just erase everything.
Oh, what type of it? You're gonna say. I know. That's why I was like, dude, you know this? I didn't give you the answer. You got the answer because you're super smart. La la la. Dude, I spent like 25. Are you kidding me?
No, like together. Still them together?
No.
Yeah.
So you had full mats? Like you opened it both? That's 500. So you probably had leftover. Oh, lame. Oh yeah?
Which tone do you think it was? One before?
Now, you notice.
God damn.
Top heading and you have. That makes sense. So it's going to take up 100% of what? But now it's all of these are 100%.
What? No, I do. You just can't. You can't see me on because you're on PS4. I have a bunch of squad winners. Yeah, there's like 5 or 6 squad winners. So we've died to the last team of duos with like a couple of my buddies. I've gone duos with a couple. I've died being getting number 2 instead of 1. Victory. Like I can't tell you. 14 times. Like raw every time. Like the best. Yeah, like the best streamer builds a lot. Ass fuck is always the last person.
Oh, that because
yeah, that's like my buddy. Yeah, that's what I usually play with.
So, okay.
Oh yeah.
Okay, I need to outside, inside.
Car symbol 3.
Okay, that's still there.
Oh, yeah, we need
I
that.
tried with 0 mark, 0.
It's a brand by
Isn't it just without commas or spaces?
Oh, I took that off too. I took off the
Whenever
with
I make new comments, I just go to starter.cpp, copy and paste it, and open into a new file, and then paste it.
I had done that
Oh, yeah, that would really suck.
it seems to be back to normal.
Oh, yeah.
Hopefully that'll stop anything like what just happened.
And in the book, when they say, because they're just doing this, right? Yeah, no, but I mean, if you did that, what is yeah, I was trying to. So when I do how should I? But like, I just assume you're looking at the big one. It's gonna look like.
I feel like this is either like back in the that's what you do. So if you want to make it flexible, right, you could have a list that
So should I get it the same and just make it look like that? I mean, like, I want it to look this big, for say,
You don't really ever want to get absolute. Because
So 2 times 0.
Well, here it is.
Well, there's some that they're just showing stuff that don't.
There's gotta be a way there.
I don't know. I only know that one was fine. This one was wrong, and these ones seemed fine, but I could be wrong. So you're giving size a value of 4, but then you're also declaring an array that has 4 indexes named X. I think that's fine. Oh, you did?
Yeah, if you follow.
I'm just gonna say not using cons.
Yeah. If you use constant integer, it's not the same as integer. That's why. You are correct.
Good catch. Worded it weird, but yeah, like yeah, it was a good discussion. That was a good catch. So this is going to be
You do percentages for everything precisely.
So you don't only use pixels for like quarters because you don't want to work it.
oh, they output the same thing. They're just written differently. Does this output less though? 1, 2.
So what analog actions will do with 100% and we'll add 1 to the order, which means that your box is plus 2 pixels.
Did you already do 5?
Mm-hmm.
Is that what you got to?
No. It wouldn't start with, it would start with 0, but it wouldn't go to 2. It would go to 4 because if you look at the...
No, because it's 2 times 1.
I know, the first line is right. The second line, if you're saying I plus 2, if I starts with 0 and you add 2, it starts at 2. And it's reading the value stored at temp 2. At temp 2, it's 4. So you would output 4. And then you start with 4 and you keep going. Because the values stored in temp in that array have been made in this for loop. And then you used it in this for loop, and then you're not using it in that for loop.
This is just C outing.
Yeah, that's outputting what's in there already, but this one, you're just editing.
You're resetting I every time. Right?
Yes.
You know that, right?
Yes.
So it's 0.
Yes. But the values stored in the array don't change. So in this for loop, it's adding 2 to 0. So it starts with, it's pulling the value of.
So this is just moving through the index.
Yes. So it starts with 4 because it's pulling the second, what's the word? It's the second value in the array, like the second spot.
So then when you're at 4 and you're at 2 to that, you're...
Yeah, then now it's 6, and then 8, and then so on.
Well, if you're at index, because you're only going to 10.
Yes.
So, okay, so if you're at 0 and you're adding 2 to it, the value that's at index 2 is 4. So then when you're adding 2 from index 4, that's index 8.
No, because you're at...
You're at index 2, 3, 4. That's value 8. You see what I'm saying?
Yeah.
And then if you're at index 8 and you're going to plus 2, that ends there because you can't pass 10.
You're right. No, the value of I doesn't... Wait a minute.
Yeah, because you're adding the I and then spitting out the value at that index, which would be here.
That's weird, because when I ran
You get what I'm talking about?
Yeah,
so
when I...
zeros, obviously the first one.
Yeah.
So then the value, so this right here is the value of each index. This is 0, 1, 2, 3, 4, 5, right? Just for your easy sake. So just like you showed me, which I agree your point. So we're shooting from index 0. We're going to do this. We spit it out, 0. Then we're going to go through again, but we added 2 to it, right?
So now it's 4.
Now we're at index 2, which is 0, 1, 2, which is 4. Spit that value out, right? And then we're going to go to, after that, then we add the 2 to it. So now we're from index 2, now we're at index 4, which is 1. So 0, 1, 2, 3, 4, which is value 8.
Yes.
And that's index 4, right?
What's weird is when I ran the program,
And then,
it stopped at 16 in the second line.
well, I think we need to go further because that's only index 4.
Yeah.
So we had index 4 to index 6, which is 0, 1, 2, 3, 4, 5, 6, which is 12.
And then when it gets to index 8, it stops at 16.
Mhm.
That's why.
Yeah.
Yeah.
So then, because we can only go to 10, so we're at 6.
I must have thought it was adding
7,
1.
8. So then it spits out 16,
And then it
but
stops.
it stops there because you need an extra one for it to go up.
And then it's out of range.
Right. That's what I think it's doing. We
Yeah,
both had pieces.
No, that's what it.
We both had pieces.
That's what it's doing. I just thought I must have misread it because I thought it was adding 1 each time.
Got it.
Input 10 numbers. Sheet.
Oh, shoot.
The weird thing is, user input stuff go after. After. So I don't know why it is. A lot of errors.
Input 10 numbers. Okay. Did it? Oh no. Uh-oh. Oh. Try this again.
This one here. This is the right next to this.
Okay, let's see. This wants us to Write a program that reads 10 integer values from a user and store
Oh, I don't have
them
it, well, yeah.
in an array.
I just copied the account.
Oh, shoot. I have brain farting on that.
Okay.
I just need this, we need to work on
Yeah.
Did it. Wait, 1, 2, 3, 4.
Just change this.
I think I'm done. I think I did it. Yeah, I did.
Right, there's a place in it for you to like write your name on the top. So
Got it.
Other than that, it's just for reference. So I normally put the H on one side.
Yeah.
And then put the C.
There we go.
See, I equals 0, I left them. Oh, because this is why. You're saying, this is saying the array of that, but what you really use for
Time to go spend the next 3 hours reading water meters.
Reading what?
Water meters.
Oh, yeah. Does your family have like walnuts or almonds or?
No, I work for the irrigation district in Durham,
Oh, sick.
and I have to read
I
every
grew up on White Drive,
white. Oh yeah, way over there, over by where
the end of the midway.
Yeah, that's way over there.
I used to ride my four-wheeler all the way through all the orchards to football practice.
Really?
Yeah.
How long ago was this?
How old do you think I am? I mean, I'm old.
23?
I'm gonna be 30 in June.
You're gonna be 30
Yeah.
in June.
Yeah.
30.
Yeah. I wear it well, don't I?
I don't think you're 30.
Well, technically I'm not. In June I will be.
I don't think
So
you
you're
look
not wrong.
that close. There's no way you're 29 years old.
Yeah.
You're 29.
It's because I'm ethnic as fuck. All the melanin's helping me out.
So what, 11 years
I love
ago?
that I got a chuckle out of it.
Wait, so you were in high school 12 years ago?
Yeah.
12 years ago, I was
13.
6 years old.
Technically, I was 007 was my graduation year.
I was in first grade. I was in first
You were
grade.
in first grade.
First grade.
So, a lot of input 10 numbers, but looks like 1 out.
I thought you were much younger than that.
Did you just?
I'm 11 years younger than you.
Did all your like?
So,
I'm like, he's probably fresh out of high school or something. No.
Right.
No. For 30 playing Fortnite, it's not bad. A lot of people play video games at 30. That's actually the average age.